the third and final video lecture covering visualizing data. We're going to talk about how to visualize numerical data today, and also note that we're going to be talking about this in lecture as well. If you've not yet watched the first two videos of this group of videos, please go ahead and do so before you start watching this one. So for numerical data, we've got several different options in which to visualize our data through graphs. Three of which that we're going to talk about in this class are box and whisker plots, histograms, and scatter plots. We briefly discussed box and whisker plots last video, so we're not going to do so again. And again, we're going to cover this in more detail in future lectures. But this particular video is going to focus on histograms and scatter plots. So in the previous video, we talked about bar charts, and these are great for categorical variables and showing the differences among these different categories. That way we can standardize all our values and observations to a single y-axis. But bar charts are pretty limited when we're thinking about numerical data. So we need a new way to show our data, and we can do so using histograms. Histograms are similar to bar charts in which they display frequency distributions, but there's some key differences here, and these differences are going to be important to pay attention to. First of which is that the x-axis are numerical data. They're not categorical data, so these can be discrete or continuous, but these are going to be numerical data, not categorical. Second of which is that the bars don't have spaces between them. And so these are two key differences in how to distinguish between the two. Also, the data are going to be binned in these histograms, and so we've learned about how to do this in the first of the three visualizing data lectures. And the y-axis has a couple different options. In this particular histogram, we can see the frequency in which the data are occurring in each one of the lengths of these flower petals, and so this would be count data. Or we can display it with relative frequency data, so percentages. Regardless of whether we're using count data or percent data, the area of each of the bars is going to represent our data. And so the taller the bars, the more observations we have in our particular sample. So in our graph down here in the bottom right, rather than having count data, we have percent data. So this is the relative frequency. And for our statistical test, this is what we're going to rely upon in order to check our assumptions and also to display our data for the most part. The reason for this is that when we display our data as relative frequency, the total area under all the bars adds up to 1. So this will be 100%. And so this is very useful when we're thinking about probabilities, which is the basis of our statistical tests, as we will discuss moving forward in this particular course. But you should be comfortable plotting a histogram, both with relative frequencies as well as count data. Now, describing histograms is important, and one way to describe them is whether they are symmetric or asymmetric. Symmetric histograms are such that if we drew a vertical line through the middle of the plot, that we could fold them in half and they would be identical to each other. Many of our statistical tests require that our distributions are symmetrical, such that we can then observe our data and we can see if our distribution is relatively symmetrical or not by drawing that vertical line and seeing if we have equal shapes on both the left and on the right. We'll talk more about this as we move forward in the course. However, not all distributions, not all histograms are symmetric. Oftentimes our data are a bit skewed, in which the data tend to stream out further to the right or to the left. And so it's going to be important for us to be able to distinguish between symmetric and asymmetric, meaning skewed data, and also describe if the data is skewed to the right or skewed to the left. So here this histogram is skewed to the right, and the reason for this is that the tail of the histogram stretches out to the right. So if we think about our distribution and our data, we've got more larger values than we do smaller values. And in order to distinguish which direction the particular data is skewed towards, you can look at the peak of the data. Here it's around 7, and then you can see which direction the tail trails off to more, and in this case it's to the right. Oppositely, left skewed data tends to have more smaller values to it, or potentially negative values to it, and that tail stretches further off to the left. So in this particular case, our peak is somewhere in the neighborhood of 24, and the tail to the left is much longer and stretched out than that to the right. Now, some distributions, they've got one distinct peak, but there are other distributions in which there may be multiple peaks, or there might not be any distinct peaks. And this is another way that we can describe a distribution and describe a histogram, is based on the number of peaks. So in the bottom right and in the bottom center here, we've got multimodal and bimodal shapes. Bimodal meaning two modes. We're going to talk about modes when we talk about central tendency in the next set of lectures. Multimodal meaning more than two. And so we can see here there's more than one peak here. And this is important when we're describing our data, so that way the reader can understand the distribution of our particular sample. Now, for a lot of statistical tests, we have a particular assumption that our data is relatively symmetric and it has one single mode. And this is going to be something that we discuss throughout the course. And this particular shape of a histogram is called bell-shaped. And for many statistical tests, we require this bell-shaped such that we can appropriately test our data against distributions that other people have looked at in the past. Okay, so how do we create these histograms? So let's go through an example to see how we do so. Let's say that we are interested in the length of a particular shark species, and we go out and we measure sharks in a particular sample, and we want to plot our data in a histogram. So what is our first step here? Well, the first step is going to be to rank order the data. This means that we're going to order the data from smallest to largest. So let's go ahead and do that. Next, the second step is going to be binning the data. So we're interested in 5 separate bins. So we need to identify the boundaries of these bins. And so in order to do this, as we discussed in the first data visualization video, we take the maximum value, we subtract the minimum value, and we divide by the number of bins to get the approximate range of our respective bins. So if we take our max and our min and divide that by 5, we find that our bin should be 16 centimeters in width. So we can then go through and start defining our bins. So the first value we start with will be 60. This is going to be our smallest value, and then we count up 16. And then we set the definition for that first bin, and then we'll go through and count another 16 and define the second boundary, so on and so forth. So from 60 to 75, this is 16 different possible observations. So our first bin is only going to have one observation. Next bin, we count from 76 to 91. That's going to have 4 different observations, and we can go through and set the boundaries for each one of our respective bins, and we can identify them such that now we'll be able to create our histogram with 5 different bins. So our fourth step is going to be to actually create our histogram. So we need to create a y and an x-axis. On our x-axis is going to be the bins, and then the y-axis for this particular situation, we're just going to use the frequency to start with. So we'll first start with our first bin. This has 1 observation, so we'll make a bar that has a y value of 1. We'll next then plot our second bin. This has 4 different observations, and note when we're plotting this that there's no space between bin 1 and bin 2. This indicates that it's a histogram rather than a bar chart. We then can plot our number of observations for bin 3. There's 6 observations here, and we can go through and plot the rest of our bins and the number of observations here. Now, as I mentioned, plotting the relative frequency of our data is oftentimes more useful, and that's how we're going to evaluate things using statistical tests. So we can make an adjustment to this. Rather than using the absolute frequencies, we can use the relative frequencies. You'll notice that the shape is similar, but it changed just slightly. And what we notice here is that the data is left skewed. There's a peak at bin 4, and this means that most of our data, most of our sharks are somewhere between 108 and 123 centimeters in length. So we can not only create these histograms, but also interpreting them is going to be of value moving forward. So when we think about histograms and bar charts, we want to make sure that we can distinguish between the two. We want to make sure that we can determine which type of data are appropriate for each type of graph, and that when provided with certain data sets, we're aware of which type of graph we should be creating. Again, categorical variable is going to be graphed using a bar chart. Numerical data is going to be graphed using a histogram. For more information, check out the text section 3.7, and I'd encourage you to work through practice exercises 3.1 to 3.3 and then check your answers. Okay, one last graph that we're going to discuss, and we're going to do so briefly because we'll talk more about this later in the semester when we talk about correlation and regression, but important to discuss now when we're talking about visualizing data, are scatter plots. Now we can use scatter plots in order to look at the relationships between two different continuous numerical variables. Again, this is a much more specialized graph in that there are very specific types of data that we use for this particular graph. And when we're thinking about these scatter plots, these are probably things that this is probably a graph that we're familiar with. Each one of those dots is going to represent one of our observations. And so in order to illustrate how to do so, let's take our length data again. But rather than just plotting length data, let's see how it relates to the weight of sharks as well. We would assume that as a shark gets bigger, based on its length, it's also going to get heavier. And so we can plot the length of our sharks against weight. Again, labeling the axes, making sure that there are appropriate numbers here and that the scale is appropriate, and then we can plot our data. And so each one of these data points represents a particular observation for a shark with both its length and its weight data. Now let's make this a little bit more complex. Let's say that we're also interested in the size of the prey of these sharks. So as they get bigger, not only are they going to get heavier, but they're probably also going to eat things that are a bit larger. One, because the sharks are bigger, they can swim faster, they can eat bigger things, but two, also their energetic needs are probably going to be larger. So we can actually add an additional y-axis to this particular plot for prey weight. We can plot that data in red with the relationship between length and prey weight, and we can then make sure that we're labeling things appropriately with a legend to distinguish between the weight of the shark and the weight of the prey. So we've gone through these relatively quickly. The reason for this is that we're going to do so in class. We're going to get some practice doing this by hand and also doing so through Excel. And also right now, I just want you to focus on being able to construct and interpret histograms. We're going to talk in more detail about box and whisker plots and scatter plots later in the semester. So histograms are what I want you to focus on from this particular video. So this marks the end of the videos for visualizing data. Some important things that you should know is making sure that you understand how to construct and interpret a frequency distribution table and a cross tabulation table. Again, we'll go through this in class, but something you should feel comfortable with coming into class. You should feel comfortable binning data based on the data set and the number of bins of interest. You should also feel comfortable getting an idea as far as how many bins you should use for a particular data set. You should be able to create and interpret pie charts, bar charts, stack bar charts, and histograms, and also be able to describe histograms with regards to their shape. Are they symmetric? Are they skewed? How many modes do they have? So, next set of lectures will focus on central tendency. These are going to include things that you're probably familiar with, mean, median, and mode, and then after that we'll follow with things like standard deviation and variance.